Hi everyone, welcome to the Databricks for Data Science webcast. I'm Andrew Kennedy, I'm a BI and Analytics consultant for Thorogood, and I'll be joined later in today's webcast by my colleague Leandro from our Brazil office to help with one of the demos. So just briefly, for those of you who aren't familiar with Thorogood, we're a specialist consultancy with over 30 years of experience delivering business intelligence and analytics solutions to leading global enterprise organizations. And Thorogood works with a wide range of tools and technologies. Now, obviously, Databricks is an important partner, and we're going to talk through some of their tools today. But also of particular relevance, we're partnered with both Amazon Web Services and Microsoft with their Azure platform. Now, Databricks is available on both platforms, but I'm going to be showing it in the Azure platform today. First up in the presentation, I'm going to introduce Databricks, and then we'll take a little bit of a tour of the Databricks interface and let you see it in action with an advanced analytics use case. Following that, I'll talk through a couple of the other tools released by Databricks to help with your data science. So that's Data Lake and MLflow, and we'll give you a bit of a demo of MLflow as well. And then finally, I'll wrap up by talking about how you get some of the insights that you've built in Databricks out to decision makers in the organization. So first off, let's start with the question, what is Databricks? First thing to note, Databricks builds on the open source Spark platform. And Spark is a popular platform for running data analysis and machine learning at scale. And the team who originally came up with Spark have formed a new company to launch Databricks. The idea of Databricks is it takes all the advantages of the Spark platform and extends it to make it easier to set up and to use and makes it ready for the enterprise. Now, one way it does that is by integrating with Azure and AWS. The Spark requires a cluster of computers to be set up, and Databricks automates this process. So it's as simple as choosing the number of computers and their size, and Databricks will handle the rest for you. On top of that, Databricks will handle the auto-scaling. So it will turn on and off machines to make sure that you only pay for the compute power that you're actually using. And that's something that can mean big savings if you're running occasional analyses that need lots of compute power for very short periods of time. Another way Databricks builds on Spark is by adding notebooks, and that's something that allows users to work in a mixture of the languages that are available, whether that's SQL, R, or Python, and you can choose between whichever language the user is most comfortable with or whatever's best for the task at hand. It also has a number of the most popular machine learning frameworks built in. Again, that simplifies the setup so that data scientists can go straight to whichever of these frameworks is best for them without having to worry about the spending time installing it that they could better spend doing the analysis and building the models. And Databricks also has enterprise-level security built in, something that's important for a lot of our customers. And it has enterprise features for collaboration and integration with a number of front-end BI tools as well. And it's all of those features combined that are making Databricks a hot technology at present. And really, we see the interest across two main types of use case. First, for the data engineering and ETL at scale, particularly with more companies embracing cloud data sources and data lakes, Databricks offers a lot of flexibility to connect to a very wide range of data sources and file types. And it allows you to use, say, Python scripts and libraries to transform the data and then output to again, whatever file type or whatever data store you need. And on top of that, the ability to scale the compute power up when needed and turn it off when you're done means that you can run your processing much quicker than you could if you were having to pay for the computers to run all of the time. And then we have the data science use case, and there really it's the flexibility to switch between languages and to use whichever ML framework you need to approach your business question. And that's a massive plus point for Databricks. On top of that, the notebook format that we'll take a bit of a deeper look into in a minute allows users to take notes in among the script, and that's an advantage because the data scientists can explain all of the steps that they're taking and hand over the output almost as a complete report, ensuring that the whole analysis is documented and repeatable in the case that any questions come up. So today's webcast, we're going to be focusing on the data science use case. I should say there's another webcast in the series which will focus on data engineering. I'll put the details up for that at the end. Now, before we dive in and take a look at Databricks, there are a couple of concepts that I want to introduce just to give a sense of what we're going to see in the tool. When we're using Databricks within AWS or Azure, you'll set up a Databricks workspace. And that's a case of filling in just a couple of details about billing, account information. It takes a few minutes to start up, but after that, everything we're going to look at today is within the Databricks workspace. Now, behind the scenes, as we make selections in the Databricks workspace, some of that's going to call out to the Azure or the AWS environment to create and manage some of those compute resources. But so long as we've got the workspace set up, we're able to manage all of that, all of the coding and all the compute resources from within the Databricks workspace itself. And as I said earlier, Databricks automates all of the complex setup behind the scenes. Now, within Databricks, there are two key things we need to get started. That's a compute cluster and a notebook. For the cluster, and the cluster really is just a set of computers to give us compute power so that when we're running the analysis, The analysis that we're building in the notebook is then run on that compute cluster. And for the cluster, Databricks keeps the options as simple as possible. We need one main computer to manage the analysis, and several worker computers to actually handle the computation steps of the analysis. And basically the key setting for the cluster is what size I want all of those machines to be and what number of machines I want to have. Once we set up a cluster, we can set up a notebook to build up the code that we need for the analysis. Now the notebook concept isn't unique to Databricks, but if you haven't come across it before, it's a way of writing blocks of code, keeping the output of each block alongside the code that generated it. And on top of that, you can provide a written explanation, you can provide charts and graphs to explain what the analysis is doing, and that makes it easier to share the output so that everything's kept together, and that gives you everything you need to recreate the analysis, say there are questions that come up later, or if you just want to make it easier to understand when you or someone else comes to look at the analysis later. So I'm going to jump into Databricks in a second and show you what all of this looks like in tool. What we're going to do, first of all, I will give you a bit of a tour around the Databricks interface, show you where we set up clusters, how we create notebooks, and then we'll take a look at an example notebook based around a project we did for a consumer goods company. So to access Databricks, I'm going to go into the browser here, and when we're accessing Databricks, this is how we'll access it. It's all online. We access it through the browser. If I go to the menu on the left-hand side, I've got a clusters option. So like I said, everything we do in Databricks will run on a cluster. If I want to create one, though, the settings that I need for that are quite simple, and the default settings actually are quite good and will allow you to do most of the analysis you want to do. So first of all, I need to specify a cluster name. We call that whatever we want. That's just a reference for us later. There are a few different things to look at, but the key ones I want to call out. We specify the size of the nodes, so the different workers where the analysis actually happens, and the driver, which is the computer that's kind of organizing the analysis and coordinating among those workers. And once we set the machine size, we then set the minimum and the maximum number of workers. So what's the smallest number of computers we want to have available, and what's the biggest. And Databricks will handle all of the scaling between that. So if I've got it set here between 2 and 8, it's going to choose a number of computers between 2 and 8 at every point in time based on how heavily my analysis is using the compute power available. So if I'm loading giant data sets and running really complex analysis on that, it might scale it right up to the 8. Otherwise, when I leave it quiet for a while, it might go back down to 2. And it's also got this option to terminate after a certain period of time. So after 120 minutes here, if I'm not taking any action, if I'm not running any analysis, after 120 minutes, it will automatically turn itself off, and that means I'm no longer paying for the compute power that I'm not using. So if I press create cluster, it would start creating that cluster, but I've already got one set up and running here. And what I'm going to do is go back to the home screen and show you one of my notebooks. Now, if you create a new notebook by clicking on the new notebook button, but actually we've got one that we created earlier. I'm going to look at one set up by one of my colleagues. Take a look at this use case for product recommendation for retailers. And this is something that we did alongside a CPG company to help them try to increase their sales by expanding the product portfolio that was being stocked in each of the stores that they supply. Our approach for this, we're going to connect and load the sales data in from Azure Blob Storage. We're going to take a look at that. We're then going to use a couple of different clustering methods to find groups of similar stores. For each store, we want to rank the products available based on their sales performance in the other stores in that cluster. And then off the back of that, we're going to recommend the highest ranked products which aren't already offered in the store. Now, I'm not going to get too deep into the specific machine learning models we're using here. What I want to show you really is the Databricks interface and how we can use it. And the first thing you'll notice here is these text comments that we have in the notebook. So I'm able to put this description at the top, and you can see there's a kind of very simple language to write that. But if I were to print this out or share it with someone else, they can very easily read the analysis. It's a little bit more friendly to read than comments in code usually would be. And then we've got these blocks of code that, in this case, I've got the default language here set to Python. So this is going to run a block of code in Python. And if I hit Control and Enter, it's going to go and run it on the cluster that we've got set up. And so this, in this case, is going back to Azure Blob Storage. It's loading the key in and connecting to that data source. We'll import a few Python libraries, so if you're used to Python, and then all these different steps that go through. Eventually, we'll get to the point where we actually load the data in from Azure Blob Storage, and this is the command that is actually going to go back out to Azure Blob Storage and retrieve that file. And if I want to show that, I can add a new command here and type display fact data. And with a very simple command, that will go back out to the data source and let me see all of the different columns, all of the different data that I've got in there. And very quickly, I get that table view. I can see what columns I have and I can see there are a few nulls in here, but I'm able to take a look and see what the data is. And if I wanted to get a visualization of that, I can just switch into the bar chart, and immediately it's chosen some of those different fields that it thinks might be useful to see. So here it's showing the average price against the channel type and the category, and I can see what the split is there. If I wanted to make changes to that, I can go into plot options here, and maybe rather than looking at the category, maybe we want to put that in the series groupings, and place month on the keys. We'll go here forward stacked. And what you'll see is we'll get a bar for each month, showing the average price in that month, added up among the categories. It's realizing average price is not the best option to use. We might want to take the overall sales quantity rather than the average price. Very quickly, I can make that change. Click in. Databricks will go fetch the data again and build that chart. So showing some of the great features here of Databricks for loading in data from multiple data sources, using the commentary, the markdown language, and showing running some of the charts and graphs and the data view that Databricks gives you. There's a couple more things to call out in here. We're using SQL to do some of our data transformation. So like I said, you can use multiple languages within Databricks, and this all happens through the use of what's called magic commands. So in this case, %SQL means that we're going to use the SQL script, but equally I can switch between Python and R back into SQL, from SQL into Scala, or whatever combination of those languages I want to use. And once I've done that data preparation step in SQL, if that's what's easiest to use to select the columns from the data set, I can switch straight back into Python and start manipulating that using the Python commands that I'm used to. Beyond that, just a couple more things to show. The first one, here we have a plot that's been brought through from Python. So I've shown you building up the charts using Databricks. If you're used to some of the Python visualization options, and the same for R, you can build those plots into the notebook as well. And then running all the way through, eventually we get through all our plots, and we get a list of the recommendations for any individual store. And here we've just built up a sample, so you can set the store number for one store, and it will tell us here are the recommendations that we're coming out with, compared with the products that are already stocked in that store, and we're getting some scores on that. So I'd say this is a kind of part-way through example from this product recommendation. The actual example was much more detailed. I'll give you a link to a webcast at the end where we talk through that use case in more detail. That is an introduction to Databricks and the tool itself. What I want to do now is talk a little bit more about how Databricks fits into the wider data science project lifecycle. And if you've attended any of Thorogood's previous data science events, you'll probably know that we like to use CrispDM as our approach to that kind of project. To give a brief introduction, with CrispDM you start with a business case for conducting some analysis with a thorough understanding of the business processes and identifying the decisions that you think you can improve by using data science. After that, you assess what data you have available, whether that data is sufficient to meet your needs, and then you progress to prepare the data for analysis, developing models and evaluating their suitability to drive the business decisions that you set out to improve. Once you're happy that the model will give you useful insight to improve your business processes, then we get to the deployment step, and we deploy the models to share the results with users in the business so that they can make decisions. And as you can see, this isn't a linear process. Often an analyst will move backwards and forwards between the different steps to continually assess the suitability of both the data and the models in meeting the end goals. And that might even mean in some cases starting again, reassessing the business processes and reframing the business questions as required. And the reason Databricks has captured the attention of the data science community is its ability to address many stages in that life cycle. That goes right from the data preparation stage, where you can use SQL, Python and R in combination to shape the data as needed. And then in the modeling stage, again, we have R and Python, which are very popular languages, especially when combined with some of the frameworks such as scikit-learn, TensorFlow, or XGBoost that are all built into Databricks. And what I want to do next is take you through some of the additional components that Databricks has to help you at various stages in that cycle. Now, the first of those that I'm going to touch on briefly is Databricks DeltaL. DeltaL builds on the data lake technology you're using already, so whether that's cloud storage in AWS or Azure. And at a basic level, the data is stored in the Parquet format that's used commonly across a wide range of tools for that kind of data lake approach. And that's something that's important because it keeps the data storage interoperable with a lot of the tools that you're using already. What it adds, though, is a lot of the features that you're used to having in some of the traditional database and data warehouse platforms. And that starts with an enforced schema, and metadata handling so that you know the format that your data has, and you can be sure that when you're running an analysis on the data, you're not going to get caught out by changes in the data structure, the formatting across the different files in the data lake. Similarly, it adds support for ACID transactions, so atomic, consistent, isolated, and durable. What that means in short is that you can build trust in a valid version of the data. So you're not going to get caught out because something like a data load fails partway through, for example. One really interesting feature of Delta Lake is that it brings together the processing of batch and real-time data into one platform. And that means that without having to rewrite your analysis, you can always be running on the most up-to-date data. And you also get tracking and versioning both on the schema and the data itself. Delta Lake comes with a feature that's known as time travel that allows you to look back at the data as it was at a specified point in time. And that can be very useful if you've run a model in the past and you need to go back and verify that the output is correct. In that case, you can specify the date and rerun the model based on the data, how it was at that point. Now, all of these things are built on top of a completely scalable data lake platform, and the features are all designed to work really efficiently at that scale. Databricks have open sourced the technology behind Delta Lake, so that means that you can use it outside of Databricks as well. But I would say that Databricks software has optimizations for Delta Lake built in, so that means that if you're using Databricks platform with Delta Lake, you'll get the best performance and all of the features that you expect from Databricks, such as collaboration and flexible compute power to run it. And that then gives you access to those alongside the advantages of Delta Lake that I've listed on the screen. I've given a very quick introduction to Delta Lake, but that's all I'm going to go into today. If you want to know more, please get in touch. I'm happy to discuss it in more detail. Or, like I said earlier, we've got another webcast coming on Databricks for data engineering, and John and Robbie will give a much more detailed introduction to Delta Lake there. Again, details for that coming at the end of the webcast. Now, next tool to touch on is MLflow, and that's another excellent addition by Databricks. This one I do want to take a little bit of a deeper look at, since it's aimed squarely at improving model tracking and management, specifically in the data science use case in the data science lifecycle. So just bringing up the Crisp DM model again, I want to remind you of some of the different stages. And MLflow helps across the data preparation, modeling, evaluation, and deployment stages. And I want to take a bit of a dig into the modeling stage and how MLflow helps there. So when we go to create a statistical or machine learning model, there are a few steps that are required to actually build the model. First, we have to choose the model type, and that will depend on the type of question that we're trying to answer. For any model type, we'll have to specify a few different hyperparameters. Then we'll train the model on our data set, and at the end, we'll review the results to see how accurate and how precise a model we've built up in that process. And we don't just do that once. Typically, that's a process that you're going to repeat many times over during the course of a project, with the aim of building more and more accurate models until you reach a model that you're happy to use to make decisions or to change how you're running the business. And this then is where MLflow comes in. It helps us to group these multiple model builds into projects. So project relates basically to a business question. In a minute or two, we'll take a look at a use case of predicting customer churn, for example. So we group all of our attempts to build a customer churn model into one project. Within each project, we can have multiple versions as we change the code and we change the models that we're producing. And a really important feature of MLflow then is the ability to track the different models that are generated. So that will keep a track of the model type, the hyperparameters you specify, and the various model metrics that you're using to judge the model's effectiveness. It also stores copies of the models, and that assists us later on in the deployment phase. And that means that we can use MLflow to access the model and run the model to get the results within either another Databricks notebook, or we can deploy the model into services such as Azure Machine Learning or AWS SageMaker. And this is what it looks like. So if we were to load up MLflow after running the analysis, you can see we get all the different model types shown across the screen in the different columns. So each run is shown in its own column. We get to see the parameters that we've set for that model run. And down at the bottom, you can see that we get the metrics. So the evaluation criteria that we're going to use to judge our model. Take a look at how MLflow works in practice. I'm going to ask Leandro from our Brazil office to take you through it in a minute. Let me just introduce what he's going to do, though. Starting with, we'll follow the Crisp DM pattern. We're going to start with the business understanding here. Our plan is to reduce the number of customers who are leaving our service, quite a common use case that we see across our customers. And the aim here, from a data science point of view, if we can identify which customers are most likely to leave, then we want to decide whether we want customer service to, say, give them a call or give them some sort of offer, just something that makes them more likely to stay with us. And obviously the numbers we've got on the screen are just example numbers, but I suggest it's always good when you're looking at this business understanding phase to try and identify the business value up front. And the data we're going to use for that, we've got data on current customers, we've got data on customers who have left us in the past, and we'll use that to look for patterns of behavior. So examples of the sort of data we might have include first order date, most recent order date, any information we have recorded on the contact they've had with customer service, or how often they're ordering or using the product. And all of that can go into building up a pattern that allows us to predict which customers are most likely to leave. Leandro's already built up a number of models that we want to test, and I'll hand over to him now to explain how we're using MLflow to track the different project runs.
So here you can manage and create different notebooks in several languages. Let me show you guys why is this so important. We are creating a machine learning algorithm to detect customer churn. It's a recurrent pipeline if you are used to work with machine learning, importing library, creating encoders, loading data files, doing some feature engineer in order to make it easier to detect the patterns, splitting in training and test, and then training the data, getting parameters, metrics to evaluate how good they are, and also storing the models. So this bit here is a little bit different if you're not used to use MLflow or any other tool to record your calls, or your runs, sorry. So here we just log a few parameters, file names and number of columns, and train size, test size, etc. And here we just log a few metrics, so accuracy, precision, recall, what was the model used, and here we log the model itself, so the trained model. And we train models using different solvers and different models. Yeah, I'm gonna use the word model a lot of times. So we use logistic regression with degree 2 polynomial kernel. We use this one here is support spectral machines, random forest, extreme gradient boosting, and always storing parameters and metrics. And then we can come here to our experiment, which is another thing you can create in your workspace, MLflow experiment, and you can compare the runs. So let me show you. So here you can compare the runs we just did. Is essentially comparing the models. So we have 5 models with 4 data sources, and we have 5 models with 3 data sources. This might happen because you don't have all the data available at the same time, but you don't want to lose information. So you might have 3 data sources available in the first day of the month, and the next one only in the second week. But you don't want to stay 1 week without consuming your information, so you create models for different data sources. And once you have a model that has the best accuracy you wanted, you can see the run here, and you can see the path you just start your model in your cluster, and then you can deploy the model just created here. So here I'm just putting that path. I'm calling that model. I'm calling files that I want to classify using my machine learning algorithm, and I'm doing the prediction. And after the prediction, I have if the customer is gonna churn or not.
Thanks, Leandro. So the final stage in the CRISP DM process that I want to look at is the deployment stage. And it's easy to look at that as something that is tacked on the end, but it's something that you really need to think about and think ahead to from early on in the process. After all, if we invest in the whole life cycle of building a model to understand what's happening in the business, the value of that model is realized when we actually use it to change the decisions we're making and to make better choices in running the business based on what the data is telling us. And so the key here is to get the insights into the hands of decision makers, and there are a few different ways we can do that. The first of those is to export data from within a Databricks notebook. So in the same way earlier I showed loading data into the notebook from a data lake, you can use Python or Scala to export to, say, a file in the data lake or push the results into a SQL database. And that will allow you to build dashboards and reports to serve to your end users in the same way that you normally would. Building on that, you can set up a schedule within Databricks so that whenever you open your dashboards, the data has already been refreshed behind the scenes and the whole process is carried out automatically on a regular basis. If you want then, it's possible to combine Databricks with other tools, say something like Azure Data Factory, so that you can build it into your data load pipeline. And what that would mean is that in the same place you set up your scheduled data loads, whether that's on a daily, weekly, or a monthly basis, you can add an extra step on the end, so that the Databricks analysis is going to run and output the data as soon as the data is available for analysis. Similar to the scheduled method, but just getting you the results as soon as the data is available. One final option, a little bit different, is to export the model from Databricks, so that outside of the tool, you can connect it directly to your front-end application. And that's an approach that you might look to if you need a real-time model results, or if you want to make more interactive requests to the model instead of just running the batch process once a day or once a week or whatever. And as we mentioned earlier, MLflow is a great tool to use for this, whether you want to deploy that model into Databricks directly itself, or if you want to deploy something like Azure Machine Learning or AWS SageMaker, MLflow makes all of that really straightforward. So the question then is how to get started. We've taken a look at Databricks across the different stages of the machine learning lifecycle, the data science lifecycle. If you think it's something that's of interest to you, I'd encourage you to get in touch. Let me know. We've helped a number of customers to get started with Databricks, and we're really happy to help you think through how it's going to work best for your organization. Just to give you a couple of things to think about as you deploy your wider analytics platform, beyond maybe just the technology question. We've looked at Databricks today, but that's not going to be everything you need for your analytical needs. So you might want to think about what's the wider tool set that it sits within. What tools do you need to allow users to find the data and find the information that they need? On the data side, then, it's important to make sure that your data science users have the right access to the data they need, whether that's coming from enterprise data sources, third-party data sets, or ad hoc data sets gathered specifically for the application at hand. Whichever of those it is, you need to have appropriate ways of storing and accessing the data and processes in place so that data scientists can get access to it. It's also important to train your people. That's both the data scientists that you want to be using Databricks and also the wider business that are going to be using the model outputs to drive the business decisions. And we always find to get the most value for the business, users need to understand not only the model itself and the outputs of the model, but also the context that sits within and how they can appropriately use the outputs of the model to drive better business decisions. And throughout all of this, you need a well thought out process. How do you identify priority business opportunities to use data science? What are the validation and evaluation criteria that need to be met during the modeling process? Once you've built the models, how do you decide which models are delivering the most value, and what steps do you take to make sure that the models are available in the right way to let people who are going to be using them make the decisions that they should be making based on the data? So I'll leave you with all of those thoughts. Like I said, if you want to get in touch and discuss any of the topics that we've covered today, I've put my email address at the bottom of the screen. The first is a video of a previous webcast that we've got on our website, www.thorogood.com. That talks you through in more detail the retailer orders prescription that I kind of showed a little bit of. But if you want to see what that use case was, I encourage you to take a look at that recording. That's the end of the webcast. Thank you for joining. I hope to hear from you shortly.